Uh, Good evening, everyone. Myself Navaneeth, and I am from PSRS. So this was my summer internship topic, which was Zemax simulation of beam expander, which I did in lab here. And my presentation is divided in four main parts: introduction, methodology, result discussion, and conclusion. So for introduction, we started with the every project starts with a motivation. Ours started when we wanted top hat beam configuration and decide to use PyShaper to convert Gaussian beam to top hat. And for that, our laser system had not had optimum input diameter to fed to PyShaper. So we thought of designing a beam shaper to increase the beam size of our laser. So my objective in this part was to simulate beam expanders using different combination of lenses in Zemax and to study conventional and cylindrical beam expanders and to construct beam expanders and to anticipate the output from the beam expanders and finally to study lens misalignments in Zemax. So our experimental setup is has shown, and we are using beam expander in between a PyShaper and a mirror, which is directly fed to the beam profiler, from where we are getting the images. So our beam expander is consisting of this is an experimental setup which had minus 75 mm and 200 mm lenses, which is a plano concave and plano convex respectively. And it had a magnification factor of 2.6. And I needed to simulate the same kind of system to check whether this beam is giving sufficient expansion to fed into the PyShaper. So the catalog of the lenses were unknown, and I had the liberty to choose the catalogs and experiment with the catalog, different catalog lenses to find a optimum and better working beam expanders. So in another part of the experiment, I also had to, this is a different experiment, I had to check with the cylindrical lenses where we are using different laser systems and different setup systems to check and to produce the laser line. And I also did Zemax simulation for this system to perfectly check the output beam parameters. And coming to the results and discussions, firstly, I will discuss to spherical beam expanders. For an ideal beam, we measured the beam profile. We measured the beam from the beam profiler, for which we had a diameter of 6.78 mm. And I am using the Thorlab lenses here, and for that simulated results, I am getting around 6.8 mm, which is almost equal to what we were anticipating. And now I go on trying to check the imperfection in the lenses. So first I try to play with the tilt in the plano convex lenses, and I played tilt along X and Y, for which the distribution or the spot diagram changes. And I did this with plano concave and combination of the lenses. What this data gives in the end is that based on the beam profiler images, we can anticipate the kind of tilt that is happening in the system. And then we can correct those tilts or decenters in the system to finally have a perfect collimated beam, which we are intend to produce. So in the last part of the experiment, I also tested with two different Thorlab catalog lenses, which are cylindrical lenses, and I anticipate, like I simulated the spot diagram, for which I got around 6.4 mm of height and width of around 2.2 mm. So to conclude, for a spherical beam expander, I had around 6.8 mm output beam diameter for an ideal system, and for even the tilt and decentered system, we rectified the setup to get ideal system. And for cylindrical beam expanders, my simulated results were around 6.4 and 2.2 and approximately. And for the measured, we had around 6 and 2 mm, and there is a plus or minus of 0.5 mm. And the effect of irregularities on spherical beam expanders were also studied. Simulation of both beam expander can also be further optimized, and simulated results are for refractive, and further it can be expanded to reflective beam expander systems, and it can also be simulated, and various other studies also can also be done. Uh, Thank you.